Hey guys, welcome back to equations of linear and nonlinear functions. So what we've talked about this week is we talked about linear functions, absolute value functions, and the last video was over quadratic functions. So we're going to finish this up today and we're going to talk about exponential functions. So this is something we haven't really talked about this semester whatsoever, and you guys really haven't seen much of it before. So how do I identify an exponential function? So the easiest way to do it is there is a variable in the exponent. So there's a variable as the exponent. Now with that variable, there can also be like other numbers up there. That's fine as well. But there's going to be a variable as the exponent. So for instance, for example, if I have y equals or f of x equals 2 to the x, that's an example of an exponential equation. And the same thing's true if I have, let's say, y equals 2 to the x plus 3. That is still an exponential function because there's a variable in the exponent. So what we're going to do today is identify exponential functions. So for the top, we're going to identify exponential functions and other functions. So how we're going to classify other functions today is if they don't fall into being a linear, an absolute value, a quadratic, or an exponential, we're going to put them as other. Okay? So they don't qualify to go into those four categories, we put them as other. So again, we're focusing on exponentials today. So let's go through. We only have a few problems we haven't classified. So number one, the exponent is a 3, the highest exponent. That's also the degree. So number one, the degree is 3. That doesn't fall into linear, that doesn't fall into absolute value, nor quadratic or exponential. So number one would be other. Okay. Number two, it's 5 to the x power. So there's a variable as the exponent. So that's going to be exponential. I like to abbreviate exponential as EXPO. It's a long word to write out, and I know you mean exponential there. Okay, so 1 was other, 2 was exponential. We already classified 3, 4, and 5 and 6 on our notes from earlier this week, so beautiful. Let's look at the rest of them. Number 7 has that cube root there. So instead of being a square root, there's a 3 there. We haven't really talked about any of that, so that's also going to be other. Okay, because we're not really sure what that is. It's called a radical, but we're not really sure what it is. And then number 8, there's a variable in the exponent, so that's going to be also exponential. Okay, so if we look at everything, we have now classified all the problems 1 through 9. We've classified every single one of them, which is awesome. Now we have to go back and evaluate them. So let's start with number 1. So all we're going to do there is take that 2 and we are going to plug it in for every single x. So I'm going to blow that up a bit. So I'm going to plug it in here. Remember, we don't mess with the left side of the equation whatsoever. Okay? So we get f of 2 equals 2 minus 4 2 to the third power. You need to remember to follow order of operations here. So please excuse exponents. So I get f of 2 equals 2 minus 4. 2 times 2 is 4. 4 times 2 is 8. Okay. Then we do multiplication. F of 2 equals 2 minus 32. So f of 2 equals negative 30. And we're done. Okay, so even though we don't know, that's actually a cubic function, but even though we don't really know what to call it, we call it as other, but we can still solve those problems. So let's move on to this next one. Again, I'm going to take this negative 2 and I'm going to plug it in for every x. So I get f of negative 2 equals 5 to the negative 2 power. So when I'm entering this in my calculator, if I remember that caret button we talked about, so when I enter this in, it's going to look something like this. I'm going to do 5 caret button negative 2. And that should cause the negative 2 to go up top to become the exponent. So when I do that, I do 5 to the negative second power, I get f of negative 2 equals 1/25th. Now some of you guys your calculators might give you the decimal, which is perfectly okay. So that's the same thing as 0.04. So either one of those answers are perfectly fine. One's just in fraction form, one's in exact decimal form, so either one would work. But that's how we evaluate an exponential. Okay? So again, really important to make sure you know how to plug these in the calculator and work through them, because you're definitely going to see this next year and on any type of standardized test or ACT or anything like that. They're going to be expecting you to kind of be able to solve these a little more. So let's do number 7. So again, I'm plugging a 0 in for everything. So what does that look like? Well, that gives me the cube root of, right? The cube root of that little 3's there, 6 times 0 minus 13 times 0. So I get f of 0 equals the cube root of, well, 6 times 0 is 0, and 13 times 0 is 0, so I get 0 minus 0. Well, I get 0, so the cube root of 0 is 0. And I'm done. If you want to know what your cube root button is, if you kind of want to play with it a little bit, on the Inspire, it's going to be Control caret. So on the Inspire, it's going to be the Control button, the blue button, and the caret button. And then you could enter in a 3, arrow down, and turn a number under the radical. Okay? So let's do our last problem. So now we have f of 1. So I'm going to take the 1 and plug it in for every single x. So I get f of 1 equals 7 to the first power minus 10. Well, anything to the first power is itself, but if you're not sure, type it on your calculator. And again, we don't do anything with that left side. We leave it alone. So I get 7 minus 10 is negative 3. So f of 1 equals negative 3. And we're done. So we have now today, this week, identified 4 different types of functions: linear, absolute value, quadratic, and exponential. There will be no video for tomorrow, because tomorrow you'll be given an assessment that we do on Sunday over identifying these 4 functions. Okay? Have a great day. If you have any questions, make sure you log on to Zoom. Thanks for stopping by, guys.